All right, so I'm going to do a quick video to describe what the robot simulator can do with respect to plotting some of the data that it might receive. So one of the problems with collecting data from the robot is that it comes in kind of a stream. You don't know how long it's going to be, and you essentially need to collect it in some kind of storage and then recall it at the end. So there is a built-in class to help with that. So I'm going to look at that. So we have this um, script right now, which is pretty much based off of the introduction that I did before, where I have a robot with two boxes and a disk connected, and the disk is allowed to spin. So in this one, what I'm going to do is I'm going to have the robot sit there, and then I'm going to turn on the torque for a little bit. So dot tau, and if you in order to write the tau, you do backslash TAW for tau, hit tab, and get that. Turn the tau on, turn the torque on for like half a second, and then leave it off. Since there's no friction, once I get it spinning, it's going to keep spinning. So let me go through. I'm going to make sure I'm going to restart my kernel just in case anything's left. So I'm going to run these, and then when I run this one, I get this, and we can see that the disk is spinning around and around and around for like 13 seconds. Okay, and I'm putting the message up that the distance of the distance. You can see it goes up and down and up and down, and so on. You get some sense for how that is, but it's a little hard to kind of visualize. And if you want to say, let's say we wanted to make a behavior that would turn until it would go to one of the corners, we'd need to kind of know some of the cutoffs for that. So a better way to look at this data is to somehow accumulate it in a storage and then recall it afterwards. So the robot itself has something called storage, where I can just add to it any numerical variables separated by a comma. So this time and the distance that I got there. The run is exactly the same. It just runs. Once it gets done, however, I can pull out those as arrays. So this picks off that storage as two different arrays that we can then plot. And so then I can do plot t comma distance and get a plot of the actual distance that is measuring. And so what you can see here actually is it starts off looking to the right. So it starts off looking over here, and it's about 20 or so, and then as it's spinning, it sees this upper corner. That's the furthest object, and it's really at a value of about 26. And then as it spins around, it gets to this point, which will be a little blip, and then it'll get very close. So then it goes down, there's a little blip, and then it gets very close. So this is looking to the left, comes back, there's a little blip for that corner, and then it starts to increase again, and it sees this corner, which is the next nearest corner, and then it'll see this final corner there. So I can look at this plot and say, okay, anything that really is above this point, above about 20, is going to be a corner. And so that's the sort of thing that we could use in order to navigate our robot. But we can also look at this as the closest point, and we can get the angle that we would need to do for that. So anyway, so this is how we can plot it. It can be any numerical value that we do. We just add to the storage and then pull it off afterward in order to visualize.